Okay, so we're going to start out with question 1. And the first thing it wants us to find is f of negative 2. So we're going to look at our graph, go up to find our negative 2 on the x-axis, go up to the line, and it happens at 5. Now it wants us to find f of 0, so we'll find 0 on the x-axis, go up, and that happens at 3. And now we want to find all solutions to f of x equals 4. So that's wanting to know, when does this function that they have right here equal 4? And so there's 4. So that happens twice on this function. Once right here at negative 1 and once here at 6. So those will be our answers, and we'll go ahead and write that as x equals -1 and x equals 6. Okay, now we're going to do question 2. And we want to determine if these graphs here, A and B, are valid functions. So the first thing we would need to do is the vertical line test. So that's going to make sure that if we draw a whole bunch of vertical lines, we don't have the same value up and down on the y-axis assigned to so we don't have two values assigned to an x value. So looking at this, the only place where we might fail the vertical line test is right here. But since this dot is closed and this one is open, we are okay. So that means A is a function, yes. Now we need to determine the domain. Okay, well, this arrow means that we go on for forever, and the domain is asking us about our x values. So we'll start at -infinity, and then we go all the way to 2. There is an x value defined, or a value defined for all x, all the way up to 2, right here where we have this dot. So we'll put 2 in a bracket, and then union, and we pick back up again right here at 4. So a bracket for the dot, 4, and we stop. We don't have an arrow here, so we don't go on for forever. We stop at x equals 8. And now the range, of this function is the y values that we're defined for. So again, we have an arrow pointing down, so we're going to start at -infinity. And then right here at -2, we have 2 open dots, which means that 2 isn't defined there. So we'll have to put 2 in parentheses, union 2, because we pick, this is -2, because we pick right back up with more values after that dot, but we can't include 2 or -2 in our range because of those open circles right there. And then we go up, and the highest value in our function is 1, and that is going to be a solid bracket because it's not an open dot. We have a whole line there. Okay, now let's look at B. So let's look at our vertical line test again. Draw a bunch of vertical lines and make sure that we don't have 2 values on the same vertical line, because then we don't have a function. So the only place that we need to look that we might have a problem is right here. And it does fail the vertical line test because we have 2 values assigned to this one vertical line. So let's go ahead and circle no. And since this isn't a function, we don't need to do the domain, we don't need to do the range. Okay, we're going to move on to question 3. So, if p of x equals negative 2x squared plus bx plus 5, and p of negative 3 equals 7, what is the exact value of b? So we need to find what that value is. So let's start by writing p of x. Just rewrite it over here. And we know that p of negative 3 equals 7. So when we put negative 3 in for x, we should get 7 as our output. So we're going to say 7 equals negative 2 times negative 3 squared, and that squared includes the negative sign, plus b times negative 3 plus 5. Okay, so that's going to be minus 2 times 9 plus negative 3b plus 5 equals 7. Okay, that's minus 18 minus 3b plus 5. That's going to be 7 is minus 13 minus 3b. So we need to move this 13 over there, and that's going to give us 20 on this side equals negative 3b, and then we divide both sides by our negative 3 to get b alone. So we get b equals negative 20 divided by 3. Okay. Question 4. So for the function f of x equals the square root of x minus a, where a is a real number, find each of the following. So first we need to find is what is the set of all input values for this function. Okay, so what are all the x's that we can put in? So first, the things that we need to remember for a square root function is we can't have negative values under our square root. So we need to look at what's under our square root, x minus a. And this is part A that I'm working on. We need to say this has to be greater than or equal to 0. And it can be equal to 0 because we can take the square root of 0. It's just 0. But when we take the square root of negative 1, that's going to be an imaginary number which we don't want. Okay, so if x has to be less than, or if x minus a has to be greater than or equal to 0, that tells us that x has to be greater than or equal to a. And we want to use interval notation for this problem. So the set of all input values for this function is going to be a. Because remember, a is a real number and x is our variable. So our values will be a, but then where do we stop? Well, there's no limit. We can take a square root of the biggest number imaginable and still get an answer. So this is going to go to infinity. Now, what is the set of all output values for this function? So if the smallest thing that we could possibly plug in is, so suppose, well, the smallest input that we can have is a, right? So if we plug in a, then we'll get a minus a, which is the square root of 0, which is 0. So 0 is going to be our lowest value. But then we didn't have an upper bound, so we could plug in a super huge number here and just bigger and bigger numbers, and we'll still get answers out from our function. So once again, we're going to go to infinity.
Okay, let's start on the next problem, 5a. So it says to find the domain of each function. So one thing to notice here is that I have some rational functions, and I also have a square root function. So for rational functions, we know that the denominator cannot be equal to 0. If it is, then the function is undefined. Also, for square root functions, the stuff underneath the square root cannot be negative. If it is, then the function is undefined. So for part A, we know that, for 5a, we know that x cannot equal negative 2.9, and also x cannot equal negative 7. Also, we know the stuff underneath the radical, x plus 6.4, needs to be greater than or equal to 0. Now, it's okay for the stuff under the radical to be equal to 0, but because the square root of 0 is just 0, it just can't be negative. So that means that x needs to be greater than or equal to negative 6.4. Okay, and so let's put these values on a number line here. So negative 7 is over here, negative 6.4 is here, and negative 2.9 is here. So I know that x needs to be greater than or equal to 6.4, so that's going to be shading this direction. And also I need to throw out 2.9, so I can throw out that value there by making a hole. I'm also throwing out negative 7, but it's already thrown out because x needs to be greater than or equal to negative 6.4. So that part doesn't end up impacting our final answer this time. So the correct answer then is going to be the interval from negative 6.4, we're including the 6.4, so I put a bracket there, to negative 2.9, open parentheses, union 2.9, negative 2.9 to infinity. So that is the domain for 5a. Let's look at b. So I noticed that the denominator is not factored. So the first thing I'm going to do is factor the denominator so that I can determine when the denominator is equal to 0, and I know those points will be thrown out. So if I factor that denominator, so let's see here. So if I factor that, I'll have x, maybe minus 5 plus 2 in the denominator. And I can see that I need to throw out x equal 5 and x equal negative 2. And so if I put that on a number line, negative 2, 5, I can put holes there, but every other x value is just fine. And so if I want to write that in interval notation, so I would go from negative infinity to negative 2, union negative 2 to 5, union 5 to infinity. So that is 5b. Okay, let's move on to problem 6. So for problem 6, it says match each function to the correct domain. Choose only one answer for each function. Write your letter choice in the space provided. So I can see that f of x is equal to 1 over x plus 1 over x minus 1. So the domain for that function would be, I need to throw out 0 and also 1. So it should be this number line for part A. So let's see which one that matches. So it should go from negative infinity to 0, union, 0 to 1, union, 1 to infinity. So the correct answer for that is I. On B, we have g of x equals 1 over the square root of 1 minus x. And so what I have there is, because it's under a square root, I know that 1 minus x needs to be greater than or equal to 0, but I also have to throw out the time when 1 minus x is equal to 0, because then that would give me a 0 in the denominator. So I need that to be strictly greater than 0. So if I solve that, I can add the x over. I get that 1 is greater than x, or I could write it the other way. X is less than 1. So that would be, if I drew it on a number line, I have 1, and I need strictly less than 1. So from negative infinity to 1, with the open parentheses at 1. So that would be B. The next one, on C, I have that k of x is equal to the square root of x plus 1 divided by 2x minus 2. So I know that the stuff underneath the radical, the x plus 1, needs to be greater than or equal to 0, which means x is greater than or equal to negative 1. And I also need 2x plus 2, 2x minus 2 to be non-zero. So if I add the 2 over and divide by 2, I need x is not equal to 1. And so if I combine that information onto a number line, I have negative 1 here and 1 here, and I have an open circle at 1 and a closed circle at negative 1. So it should be closed, negative 1 to 1, open, and 1 to infinity. So that correct answer is M. So IBM. All right, moving on to problem 7. The monthly charge for water depends on your usage. For a customer using no more than 20,000 gallons of water per month, the monthly charge is given by that, where X gallons of water are used. What are the domain and range for this function? So C of X equals 0.004x plus 15. And so the one thing we have to think about is, first of all, this is a linear function. So in general, linear functions, the domain is all real numbers and the range is all real numbers. But here I have a certain context for what I am doing here. So in this context, X is the number of gallons of water that are used. So I know that X cannot be equal to a negative number. And also we know that X is no more than 20,000 gallons per month. So X can be 0, but it also can't be any greater than 20,000 gallons per month. And then we can find the range of, so that's the domain. So I would say 0 to 20,000. And then the range would be the possible cost. So the lowest possible cost would happen when X equals 0. So if I plug in 0, I get 15 for my lowest amount of cost. And for the highest amount of cost, I just need to plug in 20,000. Because I can see that's a linear function with this increasing slope, or the slope is positive. So the largest value will be when X equals 20,000. So 0.004 times 20,000 plus 15 gives me $95. Okay, and so that is the highest cost. Now problem 8. What is the domain of that function where a is greater than 0 and b is greater than a? Write the answer in interval notation. So one thing that we know is that x minus a needs to be greater than or equal to 0. So x needs to be greater than or equal to a. We also know that x is not equal to b. So to figure out what this is on a number line, I think we need to write down, we know that a is greater than 0, so we can write 0, we can write a, and we also know that b is greater than a, so we can write b here. So x needs to be greater than or equal to a, so we can shade to the right, but we also need to throw out b. And so we can say that the domain would be including a up to b, leaving b out, and going from b to infinity. Okay. Problem 9 will be the same setup, except we know that a is greater than 0 and a is greater than b. So if I wrote that here, if I know that a is greater than 0, and we also know a is greater than b. So it doesn't actually tell us where b goes. B could either go here, or it could be less than 0. We're not sure how b compares with 0, but in fact it's not going to matter because we know that the x being greater than or equal to a means that no matter what b is, it's not going to be greater than a. So we're just shading from a to infinity. So the range here is a to infinity. Next it says the electrostatic force between two certain charged particles is a function of the distance between the particles. The relationship is given by that formula. Find the average rate of change in electrostatic force on the interval from 2 to 4. So the average rate of change is going to be the change. So this is number 10. So I want to do the change in force over the change in distance. So remember, an average rate of change is always change in the dependent variable over change in the independent variable. We might think of it like slope, like rise over run, change in y over change in x. Here in this case, the dependent variable is the force. Okay, so we can compute this, f of 4 minus f of 2 over 4 minus 2. So if I plug 4 into that function, I get 2 divided by 4 squared, which is 0.125 minus f of 2, so 2 over 2 squared is just going to be 0.5 over 4 minus 2. So if I plug that all into the calculator, I get negative 0.1875. And the units of that are going to be the units of force, which is newtons, per units of distance, which is millimeters. So what that's saying is that as the distance increases, the amount of force between the charges is going to decrease. And you might think about your experience with magnets. When you hold two magnets very close, or when you hold something that's magnetic close to a magnet, the force is stronger. When they're further apart, the force is less strong. So it makes sense that as you increase the distance, the force would be less. All right, so number 11 says, suppose that f of x equals that, find each of the following and simplify completely. So on number 11, if f of x is equal to 3 times x minus 1 squared, f of negative 2 means I'm going to plug in negative 2 everywhere I see an x. So 3 times negative 2 minus 1 squared, so that'll be 3 times negative 3 squared, which will be 3 times 9, which is 27. So the correct answer to that is 27. F of negative 2 plus h is equal to, I'm going to plug negative 2 plus h everywhere I see an x. So that's going to be 3 times negative 2 plus h minus 1 squared, which will give me 3 times h minus 3 squared. And we can leave it just like that. And then if I want to do f of negative 2 plus h minus f of negative 2 over h, I want to look at the pieces that I've already done. So this part corresponds with this value, and this part corresponds with the value 27 that I found before. So I can replace the parts that I know already where they need to go. So I have 3 times h minus 3 squared minus 27 over h. Now, to simplify further, I'm going to go ahead and square this h minus 3. So to do that, that means I'm taking h minus 3 times h minus 3. And that gives me h squared minus 3h minus 3h, so minus 6h, and then plus 9. So that gives me 3 times h squared minus 6h plus 9 minus 27 over h. If I distribute the 3, I get 3h squared minus 18h plus 27 minus 27 over h, which gives me 3h squared minus 18h, because the 27 and minus 27, that part adds to 0. That's divided by h. I can factor in h out of the top, out of the numerator. And so I get h times 3h minus 18 over h. And now that h divided by h, that divides to make 1. So what's left is 3h minus 18. All right, so, using the difference quotient from part C, what happens as h approaches 0? So sorry, I didn't do 11D yet. So the difference quotient that we got was negative 18 plus 3h. So as h approaches 0, that difference quotient approaches negative 18 plus 3 times 0, which is just negative 18. So number 12, it says first calculate f of 1 for this function, then calculate the average rates of change over the given intervals. Okay, so if I want to compute f of 1, I'm given that f of x is equal to 5 halves times x plus 3 squared. And so f of 1 would be 5 halves times 1 plus 3 squared, which gives us 5 halves times 4 squared, which is 40. So we can put in 40. Okay, so that goes here. And then I want to calculate the average rate of change from the interval 1 to 1.5. So for part B, I would say f of 1.5 minus f of 1 over 1.5 minus 1. So that's how I would compute an average rate of change. I'm given values in the table for that. So that's 50.625 minus 40 over 1.5 minus 1, which is just going to be 0.5. So if I plug all that in my calculator, I get 21.25. For part C, it's going to be similar. F of 1.1 minus f of 1 over 1.1 minus 1. And so if I do that computation, that's going to be, so I'm given that f of 1.1 is 42.025 minus 40 over 1.1 minus 1, which is just going to be 0.1. So I get 20.25. For part D, it's going to be similar. F of 1.01 minus f of 1 over 1.01 minus 1, which is 40.20025 minus 40 over 1.001 minus 1. 01. Getting too excited there, too many zeros. Okay. And if I plug all that into my calculator, I get 20.025. We didn't have units or anything, so I think we can leave those answers as they are. Then it says, as the length of the interval where h is greater than 0 gets shorter and shorter, does the average rate of change appear to approach a specific number? If so, what? So if I compare the answers for the last three things, it seems like those answers are getting closer to 20. Estimate the instantaneous rate of change at x equal 1. So that would be the same answer as part E. So we can say the instantaneous rate of change would be 20. And then, yeah, that's it for that problem. Okay, and lastly, number 13, fill in the blank. If f of A equals f of B, then the average rate of change on the interval from A to B is blank. So one way to think about this is I could think about this graphically. So if I have A and B, now I don't know that they're both positive, but just in general, and I have f of A, which is equal to f of B. That means the y values are the same y value, right? And so if I'm looking for the slope on that interval, I'm going to do the change in y over change in x. Now, we don't know what the function is doing. The function might be doing any number of things, so who knows what the function is doing. It doesn't matter because I'm looking for an average rate of change on that interval. So it's going to be so the average rate of change is going to be the change in f over the change in x, right? So that's going to be f of b minus f of a over b minus a. Now, if f of b and f of a are equal to each other, then that change in f is going to be 0. So that's equal to 0. So that's why the answer is 0 there.